Let's take a look at this peculiar product. We have a minus b times a squared plus ab plus b squared. And notice that the second polynomial is kind of the simplest thing that can be homogeneous quadratic in two variables, right? We just have every possible product of a and b, all with coefficient 1. Let's look at what happens when we multiply those together. One of these has 3 terms, so I can't use the FOIL shortcut. I'm going to put my 2 terms down the side just to save vertical real estate. And then I'll say a squared plus ab plus b squared across the top. And then I'll have a times a squared is a to the third. A times ab is a squared b. A times b squared is ab squared. Nothing remarkable so far. Then I've got negative b times a squared. That's negative a squared b. Negative b times ab, that's negative ab squared. And then negative b times b squared, that's negative b to the third. Now we have something remarkable happening. Look what happens to all the middle terms. We have a positive a squared b and a negative a squared b. We have a positive ab squared and a negative ab squared. So this pair of terms cancels out. This pair of terms cancels out. And all that's left is a cubed minus b cubed. And that came from multiplying a minus b times a squared plus ab plus b squared. All the middle terms canceled out, leaving us with a special form called the difference of cubes. So we have 2 perfect cubes, and we're doing subtraction to them, so a difference. A binomial is a difference of cubes when each term is a perfect cube monomial, the coefficient is a perfect cube number, and the powers of the variables are all multiples of 3. And then it's a difference, so one term is positive and the other is negative. So let's just see a couple of examples of differences of cubes. X cubed minus 27, that's x cubed minus 3 cubed. So each term is a perfect cube. This is a difference of cubes with a is x and b is 3. So our first factor is a minus b. So our first factor is x minus 3. Our second factor is a squared, so x squared, plus ab, so x times 3, plus b squared, so 3 squared. Or, working that out, we've got x minus 3 times x squared plus 3x plus 9. We've now factored x cubed minus 27 as x minus 3 times x squared plus 3x plus 9. Let's try a slightly more unpleasant example. So I've got 8x to the 6th y to the 3rd minus 27 again. So 8x to the 6th y to the 3rd. 8 is 2 to the 3rd. X to the 6th is x to the 2 times 3. So that's x squared to the 3rd. Y to the 3rd, well, that's just y to the 3rd. So I have 2x squared y, all to the 3rd, minus 3 to the 3rd. This is a difference of cubes again, with a is 2x squared y, and b is 3. Okay, so how do we factor this? Well, our first factor is a minus b, so 2x squared y minus 3. Our second factor is a squared, so 2x squared y squared, plus a times b, 2x squared y times 3, plus b squared, so 3 squared. And then we need to simplify in that second factor. So 2x squared y minus 3 times 4x to the fourth y squared plus 2x squared y times 3, so 6x squared y plus 3 squared is 9. And so we have a difference of cubes that factors as that product. Now, we can generalize this for any powers. We have a difference of squares, a difference of cubes. We can keep going. We could have a difference of fourth powers, a difference of fifth powers, and so on. For this class, we're just going to look at squares and at cubes.